working on the water controller circuit. So right here we have our full circuit diagram, and sitting here is our completed circuits. So we start off by detecting water, which we showed was working last week. And so you can see at this point here, this wire goes into this AND gate over here, and so that's this orange wire on the circuit over here from the water detection over to the AND gate. So that's one input to the AND gate. The other comes from this stuff up here. So we have our 1 Hz clock. That's this area of the circuit over here, and you can see the 1 Hz clock blinking. So then that 1 Hz clock, that goes into a counter, and the counter reduces the frequency, and the way we have this set up is that the output is high for a few seconds, once every 16 seconds. So you can see that blinking over here for a few seconds, once every 16 seconds. And so that's the second input to this AND gate. And then the output goes into a Schmidt trigger over here through this wire.
So, taking a look at where we are on the circuit diagram, here is the clock output and the AND gate, and here we are at the Schmidt trigger. And the Schmidt trigger turns any noisy random signal into just either -4 volts or 4 volts. And it is located here. So that's our LF356 op amp. So from the output of the clock, we're supposed to connect it, but we're finding that there's a problem that happens. So ignoring the yellow, we have the Schmidt trigger output in blue, and as you can see, it's at -4 volts, but it jumps up to -3.9 volts for 4 seconds every 16 seconds, but it should be jumping up to +4 volts. So for now, we're just going to use a function generator input to the Schmidt trigger. Okay, here on our function generator, we've got a 1 Hz square wave with a duty cycle of 20%, shown in yellow. So it goes high to 5 volts for 0.2 seconds every second, and other times it's 0 volts. And in blue, we have the Schmidt trigger working as expected. It goes high to 4 volts for 0.2 seconds every second, and other times it's -4 volts. So what's next? After the Schmidt trigger, we connect to a rectifier, which only accepts the positive output, and that's connected to a resistor, which is connected to ground. And now we NAND this output with a 3 kHz clock output, and the purpose of this is just to convert the DC signal to AC. So now when the Schmidt trigger outputs 0, that means that the output is going to be 0 over here, and then the output here is going to be 1. And when the output to the Schmidt, from the Schmidt trigger is 1, then the output is a 3 kHz, pretty much AC output that goes to the buzzer and makes it buzz. So let's try that. Here is the Schmidt trigger outputted through the diode, and then that is NANDed with the 3 kHz clock output. And then we take this output and connect it to the buzzer, and it buzzes for 0.2 seconds every second.